Welcome to the lecture series. In this series, we are going to continue the types of drone technologies which we have discussed. So, in previous series, we have discussed about the electric type, that is battery operator method of drone design. So now we are going to discuss about the fuel powered drones, that is internal combustion engine. So power source is nothing but gasoline, diesel and other liquid fuels which we usually see in a two-wheeler or four-wheeler which we use. And propulsion system is small combustion engines or gas turbines. So the engine is gas turbines which you can see here. We have a propulsion engine like we see in the two-wheeler or four-wheeler, and this is a gas turbine, and this will be operated by either with the gas, and if it's a combustion engine, it will act with the diesel and the other liquid fuels. And example is, yes, Yamaha RMAX, which we use in the drones nowadays. Advantages is long endurance, that is several hours, and have high payload capacity because it can carry a, if the combustion is high, it can carry lift the high payload also. And limitation is it is noisier. As usual, the combustion engines, it will be noisier and needs a more maintenance. Common, yes, it is used for military surveillance, agriculture sprayings, and larger area networks, etc. And next, before getting to the other type, yes, we have a brainstorm here. Which type of drone is known for long endurance flights and is typically used in military service on large scale agriculture? So if we want long endurance, and if we want large scale, and we can go for obviously fuel powered drones. Yes. Next is hybrid power drones. Yes, the power source, as we know, it's a hybrid. It's a combination of fuel engine and also the batteries. And what will be the propulsion time? Yes, electric motors powered by fuel generated electricity. Yes, you can see here we have the motors, but it will be powered by other, it will be getting the energy from the fuel generated electricity. An example, Quantorium hybrids, many custom individual UAVs. Advantages is it takes a flight time of 2 to 4 plus hours, best of both electric and fuel works, but limitation is it's quite high costly and complexity. And common uses, we can use it for long range inspection, search and rescue system. If we have landslide and forest fire in that areas, we can use it for the rescuing type. And next comes our solar power drones. Yes, we have electric power, fuel power, hybrid power, and apart from that, we have the solar power. Yes, often with the battery storage. And here also we have electric motors powered by the solar energy. Airbus, Zephyr, Facebook, Aquila, which the prototype has been developed now. Advantages is ultra long endurance, days and weeks, because it is solar power. There is no need to recharge. It automatically gets recharged when it receives the light from the sun. And it's an eco-friendly, yes, and it is autonomous. So low thrust power. Yes, it has a low thrust power and limited to the lightweight designs and weather dependent. If it is a sunny, yes, it's a high demand for this drone. But if it is a winter season, yes, this gets hit down. Common use cases, atmospheric monitoring and communication relays, research sites, etc. Yes, now we get into the brainstorming session. A drone used for high altitude atmospheric monitoring and designed to fly for days or weeks is most likely. So recall, it should be used for days or weeks, which we can go for. If it is a 2 to 4 plus hours, we can go for uh, obviously obviously it is a 2 to 4 hours, we can go for hybrid mode, but it is a days and weeks, so we should obviously go for solar power drone. So next comes our hydrogen fuel cell. Yes, we missed out one, right? So hydrogen fuel cell is nothing but electric motors powered by the chemical reaction in the fuel cells. So Dushan DS30, MMC Hydron 1800, there is some examples. You can see they have the fuel cell, and with the combination reaction, they will be hitting. And advantages is high energy density and long range and clean energy. Limitations as it's quite costly because we need of a hydrogen fuel, and infrastructure challenges with building with the high payload is very complicated, but it is used for power line inspections, border patrol, disaster response, etc. So we have discussed about the basic five types of drones drone methods based on the propulsion system alone. So these propulsion systems are still developing and hybrid modes are evolving, but still they are dependent on their applications. So in the next upcoming series we will discuss about the types of drones based on the applications. Thank you.